In this video, we are going to discuss about the synchronous design. On completion of this topic, students will be able to explain the combinational logic, and also they can able to explain the difference between the sequential and combinational logic. So why synchronous logic? So this mainly this designers of this digital integrated circuits mainly concerned on the correctness of their designs, because they have, unlike softwares, they can, the ICs are cannot be easily tested, and also real tests are not possible until the design has been finalized and the IC has been produced to simulate the behavior of the digital IC and to less guarantee that the final chip will work. So these are the disadvantages for this synchronous. So this ICs, so based on this we are writing the in synchronous design. So we are going for the synchronous design. An external clock signal triggers the IC to go from a well defined and stable state to the next one. So on the active edge of the clock, all the inputs and the output signals and all internal nodes are stable in either the high or low state. So between two consecutive edges of the clock, the signals and the nodes are allowed to change and may take any intermediate state. This behavior is predictable and will not fail due to the hazards or the glitches introduced by the irregularities of the real circuit. So mainly, this synchronous circuits are more reliable. Events are triggered by the clock edges that occur at the well-defined intervals. Also, this outputs from the one logic state have the full clock cycle to propagate to the next state, and the skew is between the data arrival times is tolerate within the same clock period. In the case of the asynchronous circuits, it is very less reliable. Delays may need to be specific amount, and also multiple delays has to be hold a specific relationship. So this is the case we go for this synchronous logic side. And the clock skew, so clock skew is nothing but it can be introduced between the two synchronous nodes and must be smaller or equal than the clock period which is present in this clock skew. So the timing period will be changing in each cases. In the case of the clock skew, if you see, means the major difference is clock arrival time across the chip. So clock skew is a temporal difference between the arrival of the same edge of the clock signal, and also it can capture and launch the flops. That is this difference in the time interval of this clock signal or two different registers can be caused by the path length differences between two clock paths. Either it can be gate or rippled clocks. So this shift register will not work because of this clock skew. And asynchronous design, so here we can see this case study. So the design which is created 2 years ago as no longer works. What did this Xilinx change in the FPGAs is SRM process improvements and geometry shrinks increase the speed, normal variations between the wafers. So this timing simulation will be in the very worst case it fails to produce the testing formation, and it is producing the less accurate in the testings, and also the actual broad levels is usually better. And in the traditional clock divider, so it introduced the clock skew, and also this it has between the two clocks, that is clock 1 and clock 2. So there are two types of clock skew. One is negative skew and the positive skew. This clock positive skew occurs when the receiving register receives the clock tick rather than the transmitting register. Negative skew is the opposite of that, that is transmitting gate gets the clock tick later than the receiving register. And clock glitches, so clock glitches is nothing but here the major difference may cause the design to manipulate when the data parts are short. And also clock glitches mainly this spatial variation will be very deterministic, and also it can be used in the modulation of the raw signal. So as we see in this clock skew, it will increase the minimum clock period and reduce the maximum clock frequency. So this is because the clock skew effectively adds to the sequencing overhead and reducing the time available for useful work. So why we have to avoid the clock glitches means so clock glitches mainly occurs due to the increase in the times. So this has to be reduced in the case of this unwanted behavior of the circuit. So one way to avoid is to gate both the clocks just before changing the select, so that when switching occurs both the clocks are low. However, there is better option available in terms of glitch free circuits, or commonly we call as the clock mugs. So clock glitching is one of the oldest and the most widely used methods of fault injection. It requires inserting short glitches into the device clock, which causes timing violations inside the device. Also, this can be removed by introducing a negative edge triggered or low level sensitive latch at the output of the clock. So this will make sure that any glitch in the circuit signal will not be visible to the gate clocked output. So coding the synchronous flip flops, asynchronous and synchronous reset. Here we use the always pause edge clock edge or pause edge. If reset, q is equal to 0, else q is equal to d bar n. Here always at pause edge clock. If reset, q is equal to 0, else q is equal to d bar n. Quiz questions in synchronous, difference between the synchronous and asynchronous. Thank you.